I had thought I assigned all the multiple choice, so we still have some calculator to do, but we're gonna wait on that because I don't want to get the two classes off from each other. So I handed out practice test 3. We will come back and do that multiple choice tomorrow, I promise. But let's look at practice test 3, which I gave you, along with the free response answer sheet. Okay? And here's what we'll do. We'll do 1, maybe 1.5 together, and then I'll set you loose, and your homework will be to finish the free response. All right, for tomorrow. So let's all stay focused, and let's get through the first one together. So we're on test 3. We're on the multiple choice, the free response. So it's at the end of the passage. Just the last few pages. And remember that number 1 and 2 are calculator. So we're going to use a calculator for problem 1. Maybe. We have a calculator if we need it. Alright, so f is the increasing function. And there I have all the values of f given to me in the chart. And then g is this other thing. And we are going to find the value of h of 8. Now, f is the chart. G is this awful equation. What is H? H is the composition G of f of x. So if I want to find H of 8, don't I want to find G of f of 8? Now, f is your chart. Look at your chart. Do you have an f of 8 value given?
Yes.
You do, and it is 15. So we're going to find G of 15. Now, I don't remember this happening on the other ones, but when it says or indicate that it's not defined, this one's you're going to be able to get a number. I got it. Negative 42.75. Make sure that's what you got. Just make sure I'm right. But if 8 was not in your F table, then you would be able to do the problem. Do you understand that? Yeah. You have to have F of 8 being defined in the chart in order to move on with the problem. How does that look? Does that look okay to everyone? Okay. And I mean, you don't have to recopy that, but I would say some kind of work that looks like this would be good. Just not this exactly, but have something down on the paper so they can tell you you got this number. All right, find the value of F inverse of 20. Somebody this morning said F to the negative first power. No. That's what it looks like, I get it. But when it's that, it's always inverse. Okay? So what are you doing? What are you thinking about if you have to find what's F? So you look at your chart. And keep in mind that, I don't know what this is. Let me call it A. That means F of A has to be 20. Would you agree with me? Because that's what it means to be an inverse. So F of what is 20? 16. So this equals 16. Remember, with an inverse, the ordered pairs are switched. Come in with us? Okay. All right, BI. Find all the values of x for which g of x, that's this awful thing, we want this to equal negative 45. So, remember, you have a calculator. So, personally, I would graph this. I would graph negative 45 And then I would look to see where they cross each other. Would that work? Okay, do that real quick for me. And tell me how many answers you came up with. So this is 1, so this is y equals, and then y equals negative 45. Second, calc intersect, and find where they cross.
How do I turn my calculator for radians again?
You want it in radians.
Oh, you do.
Yeah, your calculator for this class, it should never be in anything but radians.
Okay.
Now, we're not graphing polarly, is that what you're
I
asking?
think so. The R.
Okay, go to mode and put it in function. Given, how many points of intersection did you find?
Sorry, skip my elbow.
So we're gonna graph, this is one equation. We're gonna graph negative 45 as another equation. And then figure out where they cross. How many did you get, Jack?
3.
I got 3.
Because it bounces.
I got, oh, where did I write them down? That's this one. I got 5.321, 15.410, and 17.269.
Bless you.
Remember, you can always change your window to help you see better. And since your line is down here at negative 45, and you want to know, I don't know what this is, I don't remember what it looks like, but you want to know where it crosses this line? You could actually set Y min at like negative 40, or excuse me, Y max at negative 40 and Y min at negative 50. And that would just zoom you right in on the line that you're looking for. And then your X's. Now, I don't know, oh, never mind. That's All right, how do those look to everybody? Are you, others of you getting that? Okay. Keep in mind, there's no math involved. This is all, do I know how to use my calculator? So make sure you practice that if you're having a hard time or coming for office hours or something. All right, BII. Determine the end behavior as X increases without bound. So the limit as X approaches infinity of G of X, this is the notation you have to use. 1 point, you get 0 if you don't use the right notation. So this is our end behavior notation. We're approaching positive infinity. We'll know what happens to the function. Now, you've graphed it, but I think even without graphing it, you can answer this question. What shape is G?
Positive tribe.
It's a positive cubic polynomial, right? And what do we know about positive cubic polynomials? Start down, end up. So I don't know what's going on in there, but I know it's ending up, which means this is positive infinity. Certainly your calculator would show you that, but it wouldn't. All right. Use the table of values of f of x to determine if f is best modeled by linear, quadratic, exponential, or logarithmic. Okay, so if there is one overriding concept in this class, it seems to be rate of change, right? So let's look at our chart. These are not same size intervals, by the way. right, what's happening over here? We are not, we're not going up by ones, what are we doing? We're going up proportionally. Would you agree with that? These are my changes. They're going up proportionally. And what's happening to my y's?
Going up only.
They are linear constant. There's only one kind of main function that operates this way. Logarithmic. Yep. If your inputs are if your inputs are proportional and your outputs are linear, you are logarithm. Right? You need to explain it. CII says give a reason based on the relationship between the change in the outputs and the change in the inputs. Inputs are changing proportionally, outputs are changing linearly. What would it be if I turn those around? If these were this way, what would it be? What kind of? It'd be exponential. It'd be exponential. Right? Inputs linear, outputs proportional. All right. Let's at least get started with number 2, and then I'll set you loose and let you. I know you like working with each other better than me. All right, somebody, and I was discussing the other class last week, said something about, my gosh, there's so much words, so many words. Yes, you need to read every one of them. So there's a lot going on in this problem. Read the problem. Don't skim. Catherine, honey, read the words.
Sorry.
That's okay. You all right?
Yeah.
Does the piecewise function make sense to you? If we're talking about how much money the kid has as a function of time? Because for the first 10 months, the money just stayed 500, right? Because it was stuck in his desk drawer. So that's this. And the problem says negative time. I know that makes us a little queasy, but T is after the money's been deposited. So negative time would be when it was just hanging in the desk. All right, can we answer part A? I. Use the given data to write 2 equations that can be used to find the values of the constants A and B. What's your thought on that? Can you think of 2 equations?
$117.50 equals AB to T divided
What's the 517? Okay, so that would be 12 over 12? 1.
Wouldn't A be 500, since that's the amount we start with?
Well, I don't know, we'll talk about that in a minute. So, whoa, what you're saying, Greg, is that that's your other equation? Is that what you're saying? That A equals 500? Is that true? Think about it, at time 0, this would be b to the 0th. And don't we know when the problem started, A was 500?
Yeah.
Well, that isn't exactly the pair of equations I was thinking about, but you can certainly make a case for it. I was thinking of, was anybody else thinking of 508.67
Yeah, me too.
equals AB to the 16 6/12. But I tell you what, I think you can make a very strong case for this. Greg, I think if I were gonna do this, I would probably say 500 equals AB to the 0. Because then my equation has the A and the B involved. Is that the same thing, kids, as saying A equals 500?
Yes.
Yeah. Okay. All right. So now, that's, everybody okay? And there's 3 equations. Use 2 of them. I think they're all legit.
So they basically tell us about the 10 months that you had the money just to kind of mess with you. And it says after 10 months, the student deposited the money. Is that just to kind of mess with you?
Well, in terms of this equation, yes, because
Okay.
this equation only applies after that 10 years. I think they're trying to incorporate a piecewise function in there, and I don't know what comes next in the problem, but right here, I don't need that part, you're right, this is just that. All right, so Greg has already told us this equation says A equals 500. So if I come up here, 517.50 equals 500, basically B to the first. So I can find B, can I?
Yeah, so we,
So 517.5 divided by 500. I got B to be 1.035. Does that seem okay? So what's this equation then? This would be 500 times 1.035 to the T/12. Is that what we're supposed to be doing? Find the values of A and B as decimal approximations. So here's A and B. All right. So now I'm going to set you loose. You're going to finish this and 3 and 4. So those are 3 response homework.